Hi there, welcome back to this channel. In this video, we are going to be treating the nomenclature of organic compounds, and we are going to start with hydrocarbons specifically, or in fact, most of the compounds are going to be hydrocarbons, and we're going to be naming 50. So we are going to be going from 0 to hero. Is that okay? If you don't know anything about naming before, this video is for you, because I'm going to go from the scratch till the more advanced kind of more complex molecules that you find in exams. Is that okay? So just stick with me till the end of the video. By the grace of God, I'm going to do justice to many questions, many exam type questions that you might come across. Okay, so I have here with me a list of more than 50 molecules actually that we're going to be naming. All right, so the first thing you want to learn is the rules. Is that okay? The rules for naming organic chemistry, organic compounds. Now, the first rule is this, that you should identify the longest carbon to carbon chain. Now, when you identify the longest carbon to carbon chain, it will be your parent chain. It will be called the parent chain of that molecule. The longest carbon to carbon chain that you have identified will be the what? The parent chain of that molecule. Now, the next thing to see is to look out for substituents attached. Substituents attached. So you identify them, you bring them out. Is that okay? So after you have identified the longest chain, which is the parent chain, then the next thing to find out is the substituents that are attached. Now, what are the substituents? The substituent is going to be any other molecule or atom that is attached to that chain that is not part of the parent chain and is not hydrogen atom. Any other component, any other atom or molecule that is attached that is not hydrogen and is not part of the parent chain either is going to be called a substituent. Albeit, sometimes the attached group might be a functional group. Is that okay? But in the case where it is not a functional group, it will be called what? A substituent. All right. Any other group that is not part of the parent chain and is not hydrogen atom, that is going to be a substituent. Okay. Now, number 3 is that after identifying the position of identify the substituent, you now number your carbon chains. Number such that the substituent, let me just put S here now to represent them. The substituent gets the lowest possible number. The substituent gets the lowest possible number. So the lowest possible number. When you number, you are going to number in such a direction that gives the substituent, the position of the substituent or functional group, their lowest possible number. Now, there are some molecules that have more than one substituent attached, or will have functional group attached. If there is a functional group and not just a substituent, then, or there is a functional group and a substituent, you will number in such a direction that will give the functional group, the lowest possible number. That's to show that the functional group here takes priority or has a higher priority than the substituent. Does that make sense? That is, we give the functional group more priority than the substituent, because the functional group is the atom or molecule that determines the chemical properties of that entire molecule. So, well, we call it moiety. Is that okay? So, after numbering such that the functional group or substituent gets the lowest possible number, now the next thing to do is this. So, with this numbering, you are going to be able to identify the position of the substituents or the functional group. All right. So, after numbering such that you have the lowest possible number for the substituents. Now, in a case where there are more than one substituent, where a substituent appears more than once. That is, if I have a particular substituent that is appearing more than once on my moiety, I am going to give it the prefixes di if it appears twice. I'm going to give it the prefix tri for 3 times. If it appears 4 times, tetra, and so on and so forth. 5 times penta, 6 times hexa, like that. Is that okay? So that is the way I'm going to name it, such that if a substituent appears more than once, a particular substituent, I am going to give it the following prefixes. Now, when such also occur, you are going to use commas to separate. Use commas to separate. That is, comma to separate between numbers, and use hyphen to separate between number and letter. You use comma to separate, or commas to separate between numbers, and use hyphen to separate between a number and a letter. Okay? Now, after that, this is now the way you write your name. The name should appear the number of the substituent first, number or position, because the position is identified by the number, it carries. Is that okay? The position or location of the substituent first, then followed by the parent name. I hope this is shown. Followed by the parent name. Okay. So you go number or position of the substituent first, then followed by the parent name. So it's the parent name that always comes last. Is that okay? All right. Now we're going to apply all of this principle to naming some compounds. Now, before we also name these compounds, there is one thing you should also know. And that is the prefixes that we normally use. So, for example, if you see only one carbon, now you use meth. Is that okay? So, meth will be followed by the suffix that represents the family. So, for example, if it's an alkane, it's going to be methane. Is that okay? Single bonds all true. If it's alkene, it will be methane, with a double bond, with one or more double bond. And of course, if it's more than one double bond, it's going to be like, if it's 2 double bonds you see there, so that'll be then the prefix, then diene. Is that okay? For meth, we can't have it that way. So if I have 2 C's, so this is 1 C. 2 C's is going to be what? Air. 3 C's is going to be what? Probe. Then 4 C's is going to be what? Boot. I admit that you should already know this, but I'm going to give us to 10. Is that okay? 5 penta. Pent or penta. 6 hex or hexa. Hex. 7 hex. 8 oct. 9 non. 10 deck. Is that okay? You can continue. You can have 11 on deck. 12 dodeck. Or you see duodeck. Is that okay? Trideck 13, tetradeck 14, pentadeck 15, hexadeck. Do you see it again? These prefixes are being repeated now. Pentadeck 15, hexadeck 16, heptadeck 17, octadeck, nonadeck. Then 20 is now ecosa. Is that okay? So previously, before the 1979 revision of the IUPAC nomenclature, it was first revised. This IUPAC nomenclature was first revised in the revision of the IUC came in 1931. That's just a brief history. Then the convention we use now was revised in 1979. So prior to this time, EICOs used to be spelled E-I-C-O, so that you see, if you see that spelling, it's still the same, okay? All right. So so basically most of the questions we are going to be solving is this first 10 that we're going to be using, and that's why I give you the 10 completely. All right. Okay, another thing I would advise you to do is that make sure you are writing. Is that okay? Make sure you're jotting. So let's name our first molecule. Now, our first molecule goes like this. Okay, so we're supposed to name this molecule. Now let's apply the principles that we have already learned. So the principle we've learned begins with identifying the longest carbon-to-carbon chain. Now for this kind of molecule, it's very easy to identify the longest carbon-to-carbon chain. What's the longest carbon-to-carbon chain? It's just this straight chain here. So we have identified that. Now the second thing to do is now to see if there are substituents. Now any guy that is not on this carbon-to-carbon chain, that is still attached and is not hydrogen, that is attached to this carbon parent chain, is going to be the substituent. It's going to be a substituent. So note, identify the longest carbon-to-carbon chain, then substituent attached. That longest carbon-to-carbon chain is our parent chain, and any guy that is not on the parent chain and that is not hydrogen is going to be what? A substituent. So in this case, we have the substituent Cl. We can also mention some substituents for you. Now, when you have CH3 attached, CH3 is meth. That is one carbon. Do you remember now? But because it is CH3, it is attached to another group here. We call it methyl. Now, we have another group. If it's C2H5. So this C2H5 can be written this way again. C2H1, 2, 3, 4, 5. So the way you write this one will be attached to a particular group. The way this is usually written is CH2, CH3. It's the same. It's the same. Is that okay? In as much as it is 2 carbons and 5 hydrogen, that's going to be what? Ethyl, methyl, propyl. The same way. 3 carbons, and 7 hydrogens. 1, 2, 3, 4, 5, 6, 7. Is that okay? So if that be the case, this is going to be what? Propyl. Now, sometimes we have some common names that we give to them. For example, if you have a molecule that looks like this molecule is simple. It's just CH here, CH3 here, CH3 here, attached to another R group. And this one happens to be a substituent. This substituent's common name is called isopropyl. But the thing is, in this our naming, we are unlikely to use these common names. Is that okay? We are going to be using IUPAC nomenclature all through. IUPAC, by the way, stands for International Union of Pure and Applied Chemistry. Now, this is actually the IUPAC of this will be 1-methyl ethyl. That's it. 1-methyl ethyl. So that's the IUPAC name for isopropyl. So if we have something like this attached to the molecule, we are unlikely to name it isopropyl. We are going to be naming it 1-methyl ethyl. Okay. So let's go back to our molecule. Then there is another group that we call this R group. Those groups I just mentioned, they are called R group or alkyl group. Alkyl. The alkyl group refers to groups that are formed from alkane by removal of one hydrogen. Is that okay? It is not they are not hydrocarbons. Is that okay? It is just what we have when hydrogen has been removed from the formula of alkane. Now, of course, there's another group we call the halogens. So your what's it called? Your substance could either be an alkyl group, an halogen. It could also be a nitro group. It could also be a nitro. It could be an hydroxyl group. Now, when it is an hydroxyl group, the molecule is most likely not going to be a hydrocarbon again. Is that okay? It's going to be an alcohol. Now, You could also have the oxo group. Of course, this is now delving into other groups now. So, or it could be carbonyl. Is that okay? But basically, for most of the cases, we are going to be dealing with these three, or including this. All right. Now, if you already know how to name basic things, you can just skip the video forward. But of course, you don't need to skip because I'm going to be mentioning some stuff that you might not already know. So let's do this now. So we have identified the longest chain and we have seen the substituent. So let's number in a way that will give the substituent the lowest number. So if we number from here, 1, 2, 3, 4. We have 4 carbons, so we know our parent name is going to be boot, right? But the substituents fall on which carbon? Carbon 2, right? So because it follows on carbon 2, when you want to write your name, you should start with the position of the substituent. So which is number 2 or carbon 2. 2 what? What's the name of the substituent? Chloro. That will be 2 chloro. Now, 2 chloro what? 2 chloro what? Now, chloro, how many carbons do we have here? 4. Boot. We have single bonds all through. A. Butane. So the name of this hydrocarbon is what? 2-chlorobutane. Okay. Now let's name another one. Alright, so let's name this guy. First, let's identify the longest carbon-to-carbon chain in this molecule. Now you're going to see that the longest carbon-to-carbon chain in this molecule is definitely not this straight line, because we have to draw this straight line. If we count the number of carbons in this straight line, we're going to have 1, 2, 3, 4, 5. Is that okay? But if we start from here, for example, we're going to have 1, 2, 3, 4, 5, 6. Now, that might not still be the longest carbon-to-carbon chain. What if we counted and this portion of the molecule is called a kink or a bend? A kink means a bend. Is that okay? So if we go like this, we're going to have 1, 2, 3, 4, 5, 6, 7. So there are 7 carbons here. So let's number that way. 1, 2, 3, 4, 5, 6, and 7. So there are 7 carbons in our moiety here. Now, so this is going to be the longest carbon-to-carbon chain, that's it. Okay? Now, it means that any other guy that is attached that is not hydrogen is going to be a substituent. So these and these are substituents. Okay? So if they are substituents, what kind of substituents are they? Now you look at, you see they are the same, CH3, CH3. Alright? Forget about the fact that they are not written the same way. This is written this way because we want the bond to proceed from carbon to carbon. Is that okay? All right. And that's the right way to write it when they are terminal. Is that okay? Now, the point is this, that these guys are substituents. Now, what are their positions? If we count from here, 1, 2, 3, the first substituent will appear on carbon 3, and the second substituent will appear on carbon 3, 4, 5, carbon 5. So that's 3, 5. Remember, separate numbers by comma. Okay? Now, on this guy here, if we start from here, 1, 2, 3, first carbon will appear on, first substituent will appear on carbon 3, and 4, 5, second on carbon 5. So, whichever direction we count from, we'll get the same name, the same number for the substituent. Hence, the name of this molecule is going to be what? 3, 5. Now, the methyl appears twice. So, that's going to be what? Dimethyl. Now, 7 carbons here. How many? What number do we use? What do we use to represent 7? That is hept, right? Hept. Now, looking at this, it is single bonds all through there too. That's going to be what? A. Is that okay? Remember, single bonds, alkane, double bond, alkene, and triple bond, alkyne. Is that okay? So double, single bond, alkane, that will be the suffix. Suffix means the word that ends, the morpheme that ends words. Okay? So this is the name for this molecule. Let's go to the next one. So that was number 2. Let's name another one. Number 3. We have CH3. Now, when you have, look at a molecule like this now. So obviously with this one, this straight chain here is the longest carbon-to-carbon chain, as you can see. So this will be 1, 2, 3, 4, 5, 6, 7. 7 carbons. If you go by the bend here, it's going to give you 1, 2, 3, 4, 5, 6 carbons, which is not the longest. So the longest here is going to be what? 7 carbons. So we take this as the parent chain. However, the order, the direction of numbering now matters a lot here. If we number in this direction, we have 1, 2, 3, 4, 5, 6, 7. You are numbering the carbons. Don't forget the carbons on the parent chain. You are not going to add this. Is that okay? So first, you know that these guys here that are not hydrogen but are attached to the parent chain, they are all going to be what? Substituents. Okay? So how many substituents do we have? 1, 2, 3, 4, 5. We have 5 substituents, which means that your numbers, there must be 5 numbers when you are naming. Is that okay? 5 numbers. So with this guy now, we have 1, 2. Our first substituent will appear on carbon 2, the next will appear on carbon 4, the next will appear on carbon 5, the next will appear on carbon 6. There are 2 appearing on carbon 6. So you repeat the number 6. Is that okay? But if we wanted to go in the other direction, our first substituent will appear on carbon 2, 2 again. So because it's 1, 2, 3, 4, 5, 6, and 7. So 2, 2, then 3, following this number here, then 4. So from this number I'm showing you, you are going to already see which one is the lowest number. If you do the sum of this, you are going to get a number that is higher than this. This is 12 plus 9, that's 21 plus 2, 23. But we do this 10 plus 7, 17. So this is the numbering we are following. Notice 5 substituents, 5 numbers. 1, 2, 3, 4, 5. Okay, so we can now go on to numbering. Now, another thing is this. This methyl group and an halogen group, they have the same priority. So which one should come first will be determined by the alphabetical order. They are alphabetical ordering. Is that okay? So in this case now, we have chloro group, bromo group, we have chloro group, we have bromo group, and we have methyl group. Okay? So if we want to number this, we want to name this, which one comes first? Now you have 2-chloro, that's going to be what? Dichloro, dibromo, and dichloro. Then meth. So what comes first is going to be dibromo, because D is before the other ones. Is that okay? Alright. So bromo is on carbon 2 and carbon 6 and carbon 4. Not numerical order, but alphabetical order. Okay? So bromo is on carbon 4 and carbon 6. So we're going to have 4, 6 dibromo, hyphen between number and letter, don't forget. 4, 6 dibromo, then 2, 2. So So hyphen again between number and letter, 2 comma between numbers, 2 comma 2, because the chloro are carbon 2 and they are 2. If we gave only one, it is indicative of only one chloro. But if we give two numbers, 2, 2, is indicative of two chloro groups. Okay, so then the next substance is going to be meth, which is on carbon 3. So 2 comma 2 dichloro, then 3 methyl, 3 methyl. Then now there should be no space between what I want to write next and that methyl, but because of the longevity of the name, I'm just going to write that here. So we have, how many carbons did we have all through? 7. So that's the what? Hept. Hept. Then single bonds all through. E. Is that okay? So we have 4 comma 6 dibromo, 2 2 dichloro, 3 methyl heptane. All right. So that's the name of these moiety. So I hope that is clear. Let's go to the next one. Okay, so number 4. All right. So look at this now. In this molecule, we have different types of substituents here. All right. So the first we have to do is to identify the longest carbon-to-carbon chain. So now if we go by this, we are going to be wrong. So the longest carbon-to-carbon chain is obviously going from here. We'll go like this: 1, 2, 3, 4, 5, 6, 7. Or we'll go from here: 1, 2, 3, 4, 5, 6, 7. Okay, so either ways we go, we're going to get the same answer. So we're going like this. We are going bottom up. Okay, now it means that every other thing here that is not on the parent chain is going to be substituent. So how many substituents do we have here? 1, 2, 3, 4. Are you following? 1, 2, 3, 4. Okay, now, so how do we now number? Now, if we go by numbering this direction, obviously you are seeing that most of the molecules are tilted towards that direction. They are more in that direction rather, in that side. So you take that direction to number from. Because if we number from here, as something are going to get numbers 1, 2, 3, 3, 4, 5, 6, 7. So they are going to get 3, 3, 5, 6, 7. 1, 3, 3, 5, 7 rather. Those are 4 substituents. But if we go in that come in that direction, from that direction, we're going to have 1, 3, or 5, 5. So you see this is lower than this. If you sum this up, you're going to get 10, 18. Over here, 10, 14. You're going to get 14 here. Exactly, if you sum everything here up. So we're using this direction. So we're coming from that direction. Now, then, alphabetical order now takes priority. So now which group is this? This is methyl, M. This is ethyl, E. So obviously this is going to come before this. Okay, this group is called the amino. So once you see A, you know that it's going to come first. So it's on what carbon? Carbon 3. We'll follow this numbering. Carbon 3. Okay, so that will be 3 amino. 3 amino. This group is called the nitro. Okay, so following this, you are going to see the next one will be E. So we have 3 amino, because it's the amino group. Then the next is the ethyl group, which is on carbon 5, carbon 5. So that will be 5 ethyl, 5 ethyl. On carbon 5, still on carbon 5, we have methyl. So 5 methyl. And we can't write them together. We cannot write 5 methyl ethyl. They are different groups, so they have to be written separately. Then on carbon 1 is nitro. So you could write 1 nitro, 1 nitro. Then how many carbons did we count? 1, 2, 3, 4, 5, 6, 7. Heptane. So that is going to be the name of this guy. We have 3 amino, 5 ethyl, 5 methyl, 1 nitro heptane. Okay. Let's name another one. We have this. That's number 5. Okay, let me write 2 so that. Okay, so let's name this 2. Now, number 5 says that we have this, and of course, if you number in this direction, we're going to have the longest carbon-to-carbon chain. So meaning that this guy is a substance, this guy is a substance, this guy is a substance. Now, you might also think that if we kinked here and came here, that it is going to be the longest. It's the same, either ways you go. If you come like this will still be the substance on carbon 2, so we'll just go this straight direction. Now, these are all the same kind of substance. Now, if you number in this direction, we're going to have 1, 2, 3, 4. So our substance that are on the same carbon will be 4, 4. But here it will be 2. But we come from there, so we have 2, 4, 4. If we come from here to 1, 2, 3, that will be 3, 3, then 4, 5, 3, 3, 5. So which direction do we pick? This is going to give us 6, 4, 10. Yes, 6, 5, 11. So we are picking this direction. So our answer is going to be, because they are all equal, they are all methyls. All right, so we have 2, 4, 4. How many methyls have we? 3. So hyphen, tri. Does that make sense now? Trimethyl. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 carbons. That will be hex. Then single bonds all through. A. Does that make sense? Then in this place, now obviously the longest carbon-to-carbon chain is starting from here to this direction. These are longest carbon-to-carbon chain. Okay. So then the remaining will be substituent. So meaning this guy is a substituent, this guy is a substituent, this guy is a substituent, this guy is a substituent. Now, never you do this. Don't come like this and pick this and then go again like this. No. It has to be a long, straight tube like this. Does that make sense? All right. So these guys are substituents. So you see that these 3 substituents are alike. Now, if we go from this direction, our substituents will be on carbon 1, carbon 2, 3, 4, 5, 6, 7. But if we go from this direction, we're going to have our substance on carbon 1, 2, 3, 4, 5, 6. Obviously, this is larger, so we are coming from this direction. Is that okay? But we'll go from here. Okay, so we have our chloro are on carbon 2, carbon 3, and carbon. This is 3, 4, 5, 6, 7. And carbon 7. So that is 2, 3, 7. So we have 2, 3, 7 trichloride. Okay. In alphabetical order, the ethyl should come first. Ethyl is on carbon 5 then. So that becomes, the name of this molecule is going to be 5-ethyl, then 5-ethyl, then 2, 3, 7 trichloro. Now we have 8 carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Chlorooctane. Oct, because 8 carbons, ane, because of single bonds all through. So this is going to be the name of the molecule. All right. Now let's take this step at a time now. We have this. So obviously the longest carbon-to-carbon chain here is this, containing 5 carbons. 1, 2, 3, 4, 5 carbons. Okay? So if you go from this direction, you're going to have our substance will be on carbon 2, 2, 3, 4, 4. Is that okay? If we go from here, 2, 2, 3, 4, 4. So it means that any direction we pick, we get the same answer. Okay? So looking at this, now the amino group, we have 2 amino groups and we have 2 nitro groups. Is that okay? So the amino group will come before the nitro group. Is that okay? So we have on carbon 2 and carbon 4, right? So that will be 2, these are our substituents. So that will be 2, 4 diamino or diamino. Then 2 again, 4 dinitro. So we have 5. That will be pentane. So that's the name of that molecule. Then for this guy, we have our first substituent is on. This is going to be our longest chain. Remember, this is not carbon, this is chlorine. So it means that now you see that the substances are starting from carbon 1 here. Whenever you see that substance start from carbon 1, always consider that direction first. Always consider that direction first. So here, we're going to have our substance are chlorine on 1, 1, 1, 3, 3, 4, 5, 5, 5. So we have 1, see this carbon 1, 2, 3, 4, 5. So we have 3, so 3, is the chlorine is, the carbon is 3, is substituted twice. So we have 1, 1, 1. That is 1, 1, 1, 3, 3, 3, 3, 3, 5, 5, 5, 5. How many chlorines do we have? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. That will be heptachloro. How many carbons have we? 1, 2, 3, 4, 5, 6 carbons. Hexane. And that is the answer to that molecule. Okay? So for this one, we have one. Okay, now we are going to number in this direction like this. This is the longest carbon-carbon chain. Okay, so this is a substance, this is a substance, this is a substituent. Now if we go from here, we'll have our first substance will appear on carbon 3. So we don't want this, so we are going to take this direction. So that 1, 2, 3, 4. Oh, okay. Now, if you look at this well, if we go in this direction, this is going to be 3, 3 because there are 2 substituents, and this will be 4, 5. But if we come in this direction, this will be 2, 4, 4. So you have to be careful. You have to be careful. So which direction do we pick then? 4 plus 4, this is going to be 10, and this is going to be 11. All right. So we are taking this direction. Are going from here. So we are taking 2, this will be 2 bromo, 2 bromo, 4, 4, 4, 4. So you can see the use of writing the numbers first. So 4, 4, 4, 4, di what? Dimethyl, because it's the same group. Dimethyl, how many carbons have we? 4, 5, 6, hexane. A, because single bonds. So far, we've been treating single bonds. Now, we might soon come across double, okay, so we'll soon come across double bonds. Now, once you know how to name alkanes well, it becomes quite easier to name other hydrocarbons. And of course, other organic compounds. Only that some organic compounds use different convention. A little. All right. So let's name these guys. We have 1, 2, 3, 4, 5. 5 carbons. So we're going to be dealing with pentane in this case. And you see our two substances are on the same number. If you count from here to be on carbon 3, if you count from here to be on carbon 3. So we have 3. Now, bromo will come before chloro alphabetically. So that will be 3 bromo, 3 chloro, 3 bromo, 3 chloro, pentane, pent, because of 5 carbons, ane, because of single bonds all through. Here also, this will be the longest carbon to carbon chains. How many carbons have we there? 1, 2, 3, 4 carbons. So 4 carbons here. We're going to have, the first one is on, the first substituents, there are 2 substituents here, the nitro and the bromo. So here we have bromo on carbon 1, nitro on carbon 3. So we're going to have 1 bromo, 3 nitro, 3 nitro. How many carbons have we? 4 carbons. Butane. But because of 4 carbons, ane because of single bonds all through. Okay? Then in this case, how many carbons do we have here? 1, 2, 3 carbons. Now, 1, 2, 3 carbons, that is prop. Then these guys are substituents. Now, you see, the reason why this is arranged this way is because of there is a kind of priority that we give to their spatial geometry when there is double bonds. So we have, you see, we've got into double bonds now. So there is a respect we give to the spatial geometry. We don't just draw them anyhow. Is that okay? Structurally. So this guy is, so we have prop here, and we have 2 substituents on carbon 1 and 2. Okay? So this will be 1, 2, dichloro, 1, 2 dichloro, propene, all right? Now, propene, because it is on, the double bond appears on carbon 1. The double bond appears on carbon 1. If it appeared somewhere else, for larger moieties, we are going to have the number where it, the carbon number that it appears on, and then the ene. Okay? Then in this case, the longest carbon to carbon chain is obviously this guy here. And how many carbons do we have here? 1, 2, 3, 4, 5, 6, 7, 8. That's going to be oct, single bonds, octane. Okay? But our substituents, now how do we arrange them? We have 1, 2, 3, 4, 5 substituents. So let me name it here. 5. So now if we number in this direction, of course, is the one that will give them the lowest possible number. If we number in this direction, they can't get the lowest possible number. So we're coming here, so that's carbon 2, 1, 2, 3, 4, 5, 6. So notice that I put the number on only the carbons I need. Okay, so 2, 3 dichloro, because they are the same. Okay, there's also a chloro here, so 2, 3, 6 tri. Okay, now this is a amino group. In alphabetical order, this one should come first. So please don't make that mistake. 4, 4. So that's going to be 4, 4 diamino. Then 2, 3, 6 tri chloro. And we counted 8 carbons or single bond. A. All right. So that is going to be the name of that moiety. Okay, so how do we name this guy? Notice that there's a double bond here also. So how do we name this guy? There's no substituent at all. So this is the longest carbon-to-carbon chain here. So the only thing that we're going to take our number here is the position of the of the double bond. If you come from here to be on carbon 1, 2, 3, if you come from here to be on carbon 1, 2, 3, notice it is the bond will be in front of the carbon. So if you come from here, this double bond is in front of this carbon. So this double bond belongs to this carbon. If you come from here, this double bond belongs to this carbon. Is that okay? Depends on your direction. So either directions we go, we have 3. So this will be 1, 2, 3. Carbon 3. So that is 6 altogether. 6 carbon. 1, 2, 3, 4, 5, 6. That will be eggs. Eggs what? 2 eggs, 3 in. Okay? 1, 2, 3, 4, 5, 6. Eggs, 3 in. Okay. Now, the next one is this. Now, there's a double bond here. So don't mistakenly say 1, 2, 3, 4, 5, 6. I mean, 1, 2, 3, 4, 5, 6 is the longest carbon to carbon chain. Once there's a double bond here, we give the double bond priority. This is the order of our priority. Let me go from alcohols. So alcohols or alkanols get the highest priority in the first set of organic compounds that we learn. Then alkynes get the next. Then alkanes. Then followed by alkanes. Is that okay? So when you see these 3, this is the order in which you give them priority. Okay? So double bond here is going to get the priority. So, but obviously we cannot come this direction. We have to go that direction. So we are going like this. Okay? So if we go in that direction, therefore, we're going to have 1, 2, 3, 4, 5. We must number in the direction that gives you the lowest number, which is 1 in this case. So 1, 2, 3, 4, 5. So it's pent, right? So this guy is going to be a substituent on carbon 2. So that will be 2 carbons, ethyl. 2 ethyl, 1, 2, 3, 4, 5. Pent. Carbon 1 bears the double bond, so we don't need to put 1. Is that okay? It's not compulsory. So pentene. Because it's now what? Double bond. If the double bond appeared more than once, it will be maybe twice. It will be we'll put the number in this case. Let's say it's on carbon 1 and 3. 1, 3 diene. Okay? Now look at this. There's also a double bond here. So we're going to number in this direction. Is that okay? So we have 1, 2, 3, 4, 5, 6. 6 carbons. So 6 carbons, that's going to be hex. And our double bond is on carbon 2. Our substance is going to be on carbon 4 and 5. So we have 4 chloro. So the name of this guy is going to be 4 chloro, 5 nitro, hyphen, 5 nitro, 1, 2, 3, 4, 5, 6 eggs. Our double bond is on carbon 2, eggs, 2 in, because it's 1 double bond. So this is going to be the name of this moiety. So the next one is this guy here. Now, how do we name this? This is also going to be the longest carbon-to-carbon chain. Is that okay? And you can decide to branch anywhere. You get the same answer. Okay? If you branch down here, it's still the same. Okay, only that you not put this together. So our substituents are 1, 2, 3, 4. So it's best we go in this direction because most of the molecules are on this side. So we have 2, 2. So they are on carbon 2, carbon 3, 4, carbon 5. So we have 2, 2 dimethyl. Is that okay? But there's also bromo. Bromo comes before methyl. In alphabetical order. So that will be 4, 5. Oh, sorry. There's a double bond here. So we go from here. Is that okay? We go from here. So that will be 1, 2, 3. Okay? So that will be 2, 3 dibromo. 4, 5, 5. 5, 5. 5, 5, dimethyl actually, not methyl, dimethyl, then 5, 6, hex, 2 in, hex, 2 in. Now, there's another way you can name this. You can also say dimethyl 2-hexene, just to show that it is on carbon 2, to show that the double bond is on carbon 2. Please don't make the mistake I wanted to make then. Your priority should be on the double bond. Is that okay? The double bond. All right, so let's name this guy. The longest carbon to carbon chain here is going to be this. If you take it like this, you'll be wrong. So be very careful. The longest carbon to carbon chain is going to be like this. Then of course the double bond must be included. So I have something like this. Is that okay? So that's the longest carbon to carbon chain there. So this guy is going to be a substituent. He's going to be a substituent. So by the time we want to name, I'm going to number in this direction because it gives this guy the lowest number, the lowest possible number. 1, 2 on carbon 2. So then we have on carbon 3 our first substituent, 4, 5 our second substituent, since we have 2 substituents here. So which substance should come first, chloro group or methyl group? The chloro group will come first. So we have 5 chloro, 5 chloro, then 3 methyl, 3 methyl, 1, 2, 3, 4, 5, 6 hex, 2 in or 2-hexene, hex, 2 in. And so that's the name of that molecule. Now the next guy here, obviously the longest carbon carbon chain is going to be this. All right, so these are substituents. This guy is substituent. This guy is substituent. This guy are substituent, and they are the same. Okay, now there's also something you must see here. Now, whenever you substitute across, whenever there is the substituents are both of the guys that are bearing the sp2 hybridized carbon. Whenever, if you don't understand what sp2 hybridized carbon means, just anytime you see double bond, sp2 hybridized, you see triple bond, sp hybridized, you see single bond, sp3 hybridized. So this guy is sp3 hybridized, this guy is sp3 hybridized, but this guy is sp2 hybridized, sp2 hybridized. Okay, so whenever you see, so in this, there's also a special type of system of a naming that we give to this guy, because I told you whenever there is double bond, there is respect to geometry, because there is an angle here. Now there is a triangular kind of shape here. Is that okay? So with this now, both of these guys are on the same side. So if they are on the same side, there's a way we name. That guy that we did the other time too, that we did bromo, the bromos were on the same side and both of them were substituted, right? This also applies in case you sit in your exam. So I'm going to say, if you want to name this guy, we are going to number from that place because it gives this guy the lowest possible number, no matter the amount of substituent you have on this other side. Is that okay? So we are coming from there. So this will be on carbon 3, 1, 2, 3, carbon 4, 5, 6, 7, 8. So we are ending at oct. So the name of this moiety is going to be this. The name is going to be this. Now, which one should come first? Meth or chloro? The chloro should come first. So I have 3, 4 dichloro 6,6,7,7. Now you would think that if you go in this direction, it's going to be 2, 2, 3, 3, and that should be okay. No, because of the presence of double bond here, we respect the double bond more than the substances that are there. Is that okay? So this is going to be 3, 4 dichloro 6, 6, 7, 7. 6677 because they are the same. Methyl throughout. 77 tetramethyl oct. Now the carbon, the double bond is on carbon 3. So you can write it this way. Methyl 3 cis 3 cis. Why? Cis is a German word for the same side. For the same. Trans means opposite or the other form. That's the German word for. Because I've told you in alkenes, with alkenes, there is geometrical isomerism that we see. And there are two types. You have the cis isomerism and the trans isomerism. Now these guys, the substituents here are on the same side. So we'll call them cis, that's a cis isomerism. And if they were on different sides, as if this guy was here and this other guy was here, that would be trans isomerism. So here we can name this guy as methyl 3 cis octene. Now we're not putting the number in between because I'll put the number here. Or you say methyl 6 octene. Methyl 6 octene. So if you want to write the molecule, you are going to get that 3 is the position of double bond, and the chlorine are on carbon 3 and 4, because the double bond will occur between carbon 3 and 4. It means that the chloros are on the same side. Okay, I hope that is clear. All right, but if your exam does not add this, it's still the same. It's still correct to say methyl 3 octene or methyl octene. Okay. Obviously, again, this guy is going to be the longest carbon-to-carbon chain, so that's going to be 1, 2, 3, 4. There's a double bond here, so we are going in this direction to number. So nitro group and chlorine and chloro group are our substituents here. So this is going to be, the one that comes first is going to be, we have chloro and diamino. So chloro is going to come first, which is on carbon. We have 2, 3, 4. So that is on carbon 4. So that will be 4 chloro 2, 2, dinitro hept. We have 2 carbon 3, right? The double bond is on carbon 3 in this direction. Now we have 3E. Okay? Then for this guy also, so you're going to see here that these two groups are on different sides. So this is going to be a trans. This is going to be a trans on opposite sides. Okay? So, but the longest chain, of course, is still this. Okay? So, that way we will have the name. There's no substituent attached here, therefore. There's no substituent. So this is going to be trans 1, 2, 3, 4, 5, 6, 7, 8. Trans oct. No, there is no dash there. Is that okay? Trans oct. One, two, three. Trans oct 3. That's a simple name. Trans oct 3. Okay. So that's that. Let's move further. Alright. So I forgot to also point out the fact that we are going to be naming cyclos. And so just make sure you stick to the end. We are going to name many other. We're also going to name bicyclos. Okay, so look here. Now we're going to number, of course, in this direction because it gives this triple bond the lowest possible number. And remember, I told you this is sp hybridized, sp hybridized, sp3, sp3, sp3 hybridized. Okay, so let's go now. This is going to be how many carbons? 1, 2, 3, 4, 5 carbons, paint. Then our substance on carbon 4, 4 chloro. So that will be 4. 2 chloros are there. So we have 4 dichloro, 4 dichloro, paint, 1, 2 iron, or 2 pentyne, dichloro 2 pentyne. Okay. So the next one we have 1, 2, 3, 4, 5, 6, and our first carbon is the one that has the triple bond. Okay, so our substance are on carbon 3 and carbon 4. So we have 3, 4. Being the same, we have dibromo 1, 2, 3, 4, 5, 6 hexyne, because it's on carbon 1, so we just write hexyne or hex1-ine. Some people use 1, some people still add the 1, but it's not compulsory. Okay, so we have this guy. I'm gonna have 1, 2, 3, 4, 5, 6, 7 carbons there. So this guy is a substance, this guy is a substance, this guy is a substance. So how do we name that? If we go like this, our triple bond falls on carbon 3, which is the lowest possible number it can get there. So on this side, we have 2 methyl, that is dimethyl, and we have amino here. Amino is on carbon, we have carbon 1, 2, 3, 4, 5. Amino is on carbon 5. So we have 5 amino, 2 dimethyl, 2 dimethyl, hept 3 ine, hept 3 ine. If the ine, the triple bond appears on more than 1 carbon, maybe twice, we hept so number diene. Okay, now let's go to cyclose. With cyclose, it's best to start from the carbon that is substituted. That's the only way you can give the substituent the lowest possible number. So if we start from this carbon now. Now the cyclo must be part of the chain, parent chain. Is that okay? So you cannot go like this 1, 2, 3, 4, 5. No. The cyclo is the main chain there. So you come here, these guys are substituents. So if you go like this, 1, 2, 3, 4, it gives the substance 1 and 3. If you go like this, 1, 2, 3, 4, it gives them 2 and 4. So the best way to go is to go by numbering from the first guy, from the carbon that is substituted. If you come from here to 1, 2, 3, the same 1, 3. Is that okay? So we have, the name will be 1, 3 dimethyl. How many carbons have we here? 1, 2, 3, 4. A 4 carbon ring. A 4 carbon ring. That what? Cyclo. Do you understand now? Because it's a ring. That's what? Cyclo. Cyclobutane. Single bonds all through. So cyclobutane. Then for the next guy, this is where we number. We will number in a way that this guy will get the lowest possible number, this double bond here. Is that okay? So if we start from here, we cannot go here. We have to go here so that this guy will get below this guy will be carbon 1. If we go here, this guy will be carbon 3. Is that okay? So we go here, we have 1, 2, 3. Notice, there are 2 advantages of going like this. If you go like this guy will be carbon 1 and this guy will be carbon, double bond will be carbon 1. So if we go like this, that becomes 1 methyl, how many carbons have we? Propene, cyclopropene. Don't forget the cyclo. Is that okay? Cyclo, because it is what? A ring. Is that okay? So we are going to see many more rings now. We're also going to be naming skeletons. So make sure that you stick till the end of the video. We're going to be naming skeletons now. Like skeletal structures. Skeleton. All right. So let's name this cyclic alkane. All right. I've told you that you're supposed to number when there is no double bond or triple bond here. Number in a way that will give this guy the lowest numbers, the substrate, the lowest numbers possible. So we have 1, 2, 3, 4, 5. One thing you must know is that all these vertices represent carbon. Except substituted, you'll be seeing what is substituting it. But if nothing is written there, it represents carbon. Each vertex, carbon, represents carbons. Okay? Okay, so here we have 5 carbon ring, and we have ethyl on carbon 1 and ethyl on carbon 2. So that's what? 1, 2 diethyl cyclo, what is this? Pentane. Pent because it's 5 carbons, and ane because it's single bonds all through. Alright, so you see how simple that is. The next one is this. We have 1, 2, 3. Here we can number from any direction because there is no substituent, no double bond and all. Okay, there was a substituent here. Now let's say I put a CH3 here. We'll now start from here. Is that okay? So we have 1, 2, 3, 4, 5, 6. So this simply eggs. Egg. Is that okay? There's a double bond here. There's a double bond here and there's a double bond here, for example. This will now be 1, 2, 3, 4. Is that okay? If we go like this, 1, 2, 3, 4, 5. The first double bond we have carbon 1, but the next double bond will now be on carbon 5. So you have to go in a direction that will give the double bond the lowest numbers, which is this direction. If we go like this direction, if we go like this, it will be 1, 2, 3, 4. If we go like this, 1, 2, 3, 4. Is that okay? So in this case, this will be 1, 2, 3. So this will become 1, 3 hexadiene. This will be hex 1, 3 diene. Is that okay? Hex 1, 3 diene. Okay. Now let's look at the next one, which is this. If a number in this direction, that will be 1, 2, 3. So that will be hexane still, but now 1, 3 dimethyl hexane. Okay. Then in this case, what will this be? Even if there was a substituent here, CH3, the correct way to number is still to give this one 1. Is that okay? This guy 2, this guy 3. So this will become 3 methyl hexene. Cyclo, sorry. Oh, we are missing out the cyclo. This is cyclohexane. I'm sorry. Cyclohexane. There is no dash here. Cyclohexane. And here, cyclohex 1, 3 diene. Then here also, this will be dimethyl cyclohexane. And here, 3 methyl cyclohexene. Alright, I made the mistake trying to conserve space. Okay, this is 31, this is 32. Alright, let's name this guy. So this is a skeleton, just like this ones too. Now, each vertex here represents a carbon atom. Each vertex represents a carbon atom. So we're going to have 1, 2, 3. You start from here, is that okay? 1, 2, 3, 4, 5, 6, 7, 8. Now, if you want to draw, it's the same way. If you want to draw, for example, something that has 5 carbons, you start like this. 1, the first point you make is 1, 2, 3, 4, 5. Is that okay? So we have 1, 2, 3, 4, 5. Okay, pentane. All right, so but my point is this. Here, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So if we go like this, we have 1, 2, 3, 4. This guy will fall on carbon 4. If we come like this, 1, 2, 3, 4, 5 on carbon 5. So it means we should go like this. So we have 1, 2, 3, 4. So that will be 4. Now in common name, this is isopropyl. But we don't want to use isopropyl, we want to use IUPAC. So that will be 4 methyl. This will be 4 methyl ethyl usually we write in brackets this way. Let me show you something. So we write it in bracket this way. So we have 4 1 methyl ethyl. Is that okay? 4 1 methyl ethyl 1 2 3 4 5 6 7 8. That's oct. And we just go octane. Is that okay? Or 4 isopropyl octane. Okay? So that's the answer there. Then for this one, we have the number in this direction to give this double bond. Once there's a double bond, your priority is the double bond, as I have said. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're ending with oct, also octene. So this becomes 4. Now this is methyl, these guys are the same. So, and this one is ethyl. So we have 5 ethyl. 5 ethyl, 4,6 dimethyl oct 2-ene. All right. So that's the name there. Then for this one, now this is carbon 1, this is carbon 2, this is carbon 3. Students usually confuse this the skeleton of alkynes rather, and it's because of this place here. Now this is geometrically correct. Some people, I've seen some people draw this way, and you see something like this. Now this is incorrect because there is a linear shape between these carbons. These carbons are linear. There's a linear geometry with sp3 sp hybridized carbon is linear. Do you understand? The shape is linear, so it has to be like this. You understand? So that there should be no, for example, if you want to draw this thing I just drew here, there will be no kink here. Just go directly like this. So like this. So this will be carbon 1, carbon 2, carbon 3, carbon 4. Is that okay? And in this case, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? With no substance attached. Let's say there was substance attached here. We'll still go in this direction. If we go in this direction, let's say we attach a substance here, maybe methyl. This will now be 1, 2, 3, 4, 5. We'll go like this because this direction gives it 4. So that will be 7 methyl, known 4-ene, rather, known 4-ene. Okay, then number 32 we have this guy here and this guy here. We're gonna have, so this is nitrogen, is carbon 1, 2, 3. Only these three are carbons. So that's prop. So prop, that is 1, 3, 1, 3 diamino pro propane. Okay, propane. All right, let's name some more. We're going 16. All right, we'll soon get into naming bicycles. So let's just finish off with these skeletons. So you see this guy. Now there's a double bond here. So the longest carbon to carbon chain here is going to be 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. The other way you look at it. So I want to go like this: 1, 2, 3, 4, 5, 6, and 7. So if that's the case, then it means this is a substituent ethyl, substituent methyl, substituent methyl. So that's what we have. So our substituents are on carbon, methyls are on carbon 4 and 5. So we have 4, 5 dimethyl. Then 5 ethyl. 5 ethyl. 5 ethyl, then 7 carbons. That's going to be hept 2E. Okay? Alright. So that's the name of that molecule. Then for this one, we're going to have 1, 2, 3, 4, 5. Now, you cannot go here 1, 2, 3, 4, 5, 6 because there's a double bond here. So you have to honor that double bond. So let's go from double bond. 1, 2, 3, 4, 5, 6, 4. So you see, the longest is actually 1, 2, 3, 4, 5, 6. Notice it's not touching. So the 6. So it means this guy substituent, this guy substituent. Alright. So our substituents are appearing on carbon 3 and carbon 3, 3. So here it's going to be, this guy is going to be ethyl, methyl. So we have 3 ethyl, 3 methyl, 6 hexene. Hexene, I don't need to put the 1. Is that okay? Hexene. Then in this case also, we have carbon 1, 2, 3, 4, 5, 6, 7. So what does this become? This becomes 3 methyl. I have to go in this direction because if I come in this direction, these double bonds will get greater numbers than if I go like this. So I'm going to have carbon 1 and carbon 5 bear the double bond. So I'm going to have 1, 5, then 3 methyl, 1, 5 di, hept, 1, 5 diene, hept, 1, 5 diene. Okay? Then in this case, there is a cyclo. Don't forget there is a cyclo. So the correct direction to number is just here. From here, 1, 2, 3. If you start from anywhere here, it's going to give this double bond the lowest number. Notice your priority is double bond here still. So that will be 1, 2, 3. Because it's the same thing, ethyl, ethyl, ethyl. Those are the substrates there. If there's something different, it's still the same way. Is that okay? So 1, 2, 3, try ethyl. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 6. Hex. Cyclohexene. Don't forget that. Cyclohexene. Alright. Cyclohexene. Okay? So let's go on to naming bicycles. Alright. So let's name this guy now. Alright, so how do you name this guy? Okay, so I think, okay, there is a double bond here. Alright, so So how do you name this guy here? Of course, you know that there is a double bond here, so the priority should be given to the double bond. So start from here to number 1, 2, 3. Now we're going to go 4, 5, 6, or 4, 5, 6, 7. We're obviously going here. Alright, so we have our substituent ethyl, okay? So that will be 2 ethyl, 4 ethyl, that will be 2, 4 diethyl. 2, 4 diethyl. Diethyl heptene. And of course this now, here we have bicycles here. We're going to start bicycles soon. So let's name this last one. With this one, because I've told you, you should number not with respect to the substituent, but with respect to the double bonds here. So we start from here, 1, 2, 3, 4, 5, 6, 7. Bromo gets the 7th. Okay, but if you start from anywhere else, these double bonds will get a higher number than this. You start from here too, they will get the same number that I just did. Like you start from here, 1, 2, 3, 4, 5, 6, and 7. Is that okay? Well, I'm deciding to go in this direction. So this will have what? Carbon 1, carbon 3, and carbon 5 are our double bonds. Are the carbons bearing our double bond. Then 7 is the carbon bearing bromo. So I'll be 7 bromo, 1, 3, and cyclo, 1, 3, 5, hept, that'll be cyclohept. With cyclo, we cannot write the number before that guy. Especially when the double bonds are more than 1. Is that okay? So hept 1, 3, 5 triene. Hept 1, 3, 5 triene. So we still obey all the laws. Hyphen between number and letter, comma between number and number. Alright? Then now we've gotten to cyclos, bicyclos. Bicyclo, because the word bi means 2, cyclos means 2 rings. So there are 2 rings here. Now to name bicyclos, this is how you do it. You start numbering from the carbon, bridgehead carbon. Is that okay? We call them the bridgehead carbon. That's the name. Like, just so you know, not like I'm gonna write that in the name. So the bridgehead carbon, you look for the bridgehead carbons now. The bridgehead carbons is the carbon that the carbons that form the bridge. Okay, and here we have this guy here, this carbon here, and this carbon here. For this case here, we have this carbon here and this carbon here. They are the bridgehead carbons. Okay, now after identifying the bridgehead carbon, you pick one of the bridgehead carbons to start with. So if I'm starting with this bridgehead carbon, then I will go in which direction will I now go? I will go in the direction of the ring that has the greatest number of carbon. If, because of substitution, that's the reason. If the bridgehead carbon, if I pick this as my bridgehead carbon, I will not go this direction. Why? Because how many carbons do we have here? We have 1, 2, 3 carbons. On this side, how many carbons do we have? We have 1, 2, 3, 4 carbons. So I'm going to go in the direction of this ring. But of course, if my substitution is here, let's say I have a substitution chloro group here, I will not pick this bridgehead carbon. I'm going to pick this bridgehead carbon and still go in this direction. Why? Because this bridgehead carbon will give this number, this chloro group, its lowest number. But as there was no substitution here yet, how do we name? So how are you going to name this guy? Now the bridge, you are going to start with the name bicyclo. Now you now open a square bracket. Now you open square bracket and write in descending order, that is from the highest to the lowest. The highest here is the highest ring here, the ring with the highest number of carbon is this one, that will be 4. Then the next ring is the one that has the next number of carbon, which is 3. So dot 3. Then this bridgehead there's no carbon in between these two bridgehead carbons, so there is 0 carbon. So we say 430, then we close the square brackets, and then we now have the name. How many carbons do we have in total? So we're going to have here 4 plus 3 plus 1, 2. So that's going to be 4 plus 3, that's 7 plus 2, that's 9. So here we're going to have no name. Known because of 9 carbons, and aim because of single bonds throughout the rings. Okay, now let's consider the next example. Following the same process, I'm going to start with the bridgehead carbon. How many carbons do I have here? 1 and 2. How many carbons have I here? 1, 2 and 3. So with this one, I'm going to go in this direction. If I decide to start here, now notice that there is a carbon here. Okay, within the bridgehead carbon, there's going bridgehead carbons, there is one more carbon. Okay, so here we're going to go in this direction, 3. So we say bicyclo, we open parenthesis, square brackets, then we start with the IS, which is 3.2.1. Is that okay? Then we close square brackets and have our this guy here. Then how many carbons are we in total? 3 plus 2, 5 plus 1, 6, 7, 8. That will be octane. So bicyclo 321 octane. Bicyclo 321 octane. Now let's do some that have to do with substitution, where there is the carbons are substituted. So how do we name these guys now? And it is very simple. What you want to do is this. You see, we said that the first thing you do is write bicyclo to show that there are 2 rings here. Then you open parentheses. Now you now start to number from the ring with the highest number of carbon on the other side across the bridgehead carbons. So these are our bridgehead carbons here, this guy and this guy. Okay, so take note of that. So this guy, he has 1, 2 carbons. This guy has 1, 2 carbons. Okay. Now, because both of them have the same number of carbons, where do we go? We are going to go in the direction of one that has a substitute that is substituted. So that has a substituent, that's what I mean. So there's a chloro group here. Okay. So we're going to go in this direction. So we are going to have 2, 2. Now, if you look at within the bridgehead carbon also, we have what? 2 more carbons. So we are going to have what? 3. This is going to be 2, 2, 2. Yes. So that's going to be 2.2.2. Why? Because all of them have 2 carbons in the ring. Okay? All right. Then how do we now write the substance? The substance is on carbon. Now, how do we number? I've told you we number in the direction of the carbon that has the highest number. So we're going to have, this is going to be 1, then this will now be 2, 3, 4, 5, 6. Is that okay now? Then 7, 8. Is this clear? We're going to have what? 1, 2. So that chlorine here is going to fall on 2. So this now becomes what? 2 chloro. There's going to be a dash here, yes. 2 chloro. 2 chloro. How many carbons all through? 8 carbons. 2 chloro octane. 2 chloro octane. 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 Alright? For this guy also, follow me. We pick the bridgehead carbon. Now we pick this bridgehead carbon. We pick this guy here. I'm going to number in what direction. Obviously, this guy has more carbons and he's also substituted. Is that okay? He's also substituted. If this one is substituted here to closer to this carbon that we pick, we doesn't know we'll go there. We'll still go to the one with the highest number of carbon. So this guy has 1, 2, 3, 4, 5. sorry, 1, 2, 3, 4, here, 1, 2, 3, okay? So 4 carbons here, we're going to have bicyclo, that's when we always go, bicyclo, then we open a bracket. How many how many carbons are we in this ring? 4. How many on this one? 2, 3, 1, 2, 3. Now, across the bridgehead, how many carbons do we have? Only none. We don't have any one, right? So that would be 0. 4, 3, 0. Square bracket. Square bracket. Then, now this guy is now substituted. How do we count? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So this guy is going to get carbon 2. So it's going to be on carbon 2. If you number anywhere else, anyhow else, these guys will get different numbers. Because we go like this now. This is 1, 2, 3. Bromine will get 3, 4, 5, 6, 7, 8, 9 for bromine. So this is the one that will give them the lowest possible number. So this will be 2 bromo, 8 chloro, 8, that dash, this hyphen is here, 8 chloro, 9 carbons, that was no name. No name. In because it's single bonds all through. And if there was a double bond somewhere, is that okay? The double bond will now take priority. In further on, maybe we'll do double bonds, the one that has double bond. So how do we name this two? Bicycle. Now here we have the carbon here bears the substituents, okay? Bridgehead carbon rather bears the substituents. Both bridgehead carbons bear substituents. Either ways, we are still going in this direction. So we have 1, 2, 3, 4 carbons here. So that will be bicyclo. 4. How many carbons do we have here? 1, 2. 4, 2. Then no carbon within the bridgehead carbons. 4, 2, 0. Then we have our substituents are on carbon 1. So we go like this. 1, 2, 3, 4, 5. We go like this. 1, 2, 3, 4, 5. Let's number 1, 2, 3, 4, 5, 6, 7, 8. Now we cannot go like this. We can't go 1, 2, 3, 4, 5, 6. But we can't skip to that. You know what I'm saying? So we have to go like this. Okay? So this is carbon 1 and carbon 6. So we have what? 1, 6 dichloro 8 octane. Single bonds also. Okay? The next case, we're going to have this guy. These are our bridgehead carbons. We go, this has 1, 2 carbons, this guy has 1 carbon, okay? So we're going to have 1, so we're going to have bicyclo. 1, 2, that's 2, 1. 1, this also has 1, right? 1 carbon. 2, 1, 1. So if we go in this direction, that will be 1, 2, 3, 4. 4 bromo. 1, 2, 3, 4. 1, 2, sorry. 1, 2, 3, 4, 5. 5 bromo. Always count from the bridgehead carbon. 5, then 6 octane. 6 hexane, sorry. Hexane. That's from exhaustion, sorry. Alright, let's go to the next one. We're going to 50 now. Alright, so for this one, we'll go by the same principle. We have bicyclo. Starting with the bridgehead carbon. The bridgehead carbons are going to be here. You can decide to take Now, seeing this, you're going to have, if you pick these two sides, if you pick this as your bridged carbon, the carbon between your bridged carbon, you're going to have two carbons in between here to 1, 2. Two carbons in between here too. So either one you pick, you're going to be correct. So that will be 2 dots, 2 dots, 2. But note that you must number in descending order. But because they are the same numbers here, we are just going like that. So bicycle, how many carbons do we have here? 1, 2, 3. Number in any direction now because it's the same. So 1, 2, 3, 4, 5, 6, 7, 8. Bicycle 2, 2, 2, octane. Okay. Now for this one, I'm gonna have this. This will become, now we want to name, we're gonna start from this bridged carbon. We can't go here, do you know why? Because we have 1, 2, 3, 4 carbons here. But if we go here, we have 1, 2, 3, 4, 5 carbons. So we have to go in the direction of the one that has the highest number of carbons. So here it's going to be 1, 2, 3. So we start with bicycle again. Our square brackets. How many carbons do we have here? 5. How many carbons do we have on the other side? 4. 5, 4. How many carbons are in between the bridges? No, 0. So that will be 0. 4, 5, 4, 0. Now, how do we now number? We now go like this: 1, 2, 3 in that direction. 3 methyl, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this will be 3, 11. 3, 11 dimethyl unodecane or undecane. Okay. Then for this guy here, we're gonna have our bridged carbons. We go in this direction. Let's say there was a double bond here. Let's even put a double bond because we obviously can name this already. So let's say there was a double bond here. Here, for example. Okay? So this is going to be 1, okay? 2, first bicycle. We're starting bicycle. Don't forget that. Now, here we have 1, 2, 3, 4 carbons. On this side we have 1 carbon. Here we have 0 carbon. Is that okay? Check the highest side, then the next side, then the in between them. Is that okay? That does not mean, if this guy has, for example, if this side was like this, it will be 4, 1, 2, 2, then 1. Is that okay? It doesn't mean we are going left side then center, no. Okay? Because in that case, this guy will be the center, kind of. Okay? I don't know if you understood what I explained, but this order is not like left side center. Okay? So now, so in this case, we now number like this: 1, 2, 3. So 2, 3 chloro, dichloro. 2, 3 dichloro. How many carbons do we have? 4, 5, 6, 7. 7 carbons. Hept. Now we have double bond here. Now we have 3 in. F3 in. I hope that is clear. Okay. Look at this one also. We have a double bond here. The same process. And we have 1, 2, 3 carbon. Here, 1, 2, 3 carbon. Okay, the equal number of carbon. So start. Bicycle. 3, 3, no carbon here, 0. Then 1, 2. So our double bond is on 2. If we go like this, 1, 2, okay, double bond is also on 2 here. No, 1, 2, 3, rather. sorry. You know, you're always starting from here. So you start from 1, 2, 3 now. Well, we come here, 1, 2. So start from here, 1, 2. So that will be 2, 3, 4, 5, 6, 7, 8. So that will be oct. 2. I hope that is clear. All right. And let's do the last two. All right, let's name those two last molecules. Okay, so the first one here, we have something like this. Now let's identify the bridgehead carbons. The bridgehead carbons are here and here, okay? So now there are two ways you can see it. Is it that we see it this way, that the bridgehead carbons have 2 carbons within it or 3 carbons within it. Is that okay? Either way is the same thing. You are going to see this now. Look at bicyclo. Now the highest here is going to be 1, 2, 3, 4. So that will be 4, 1, 2, 3, dot 3, 1, 2, dot 2. Okay? Now there is a double bond here. So because of that, we have to go in this direction first. So it has to be 1, 2, 3, 4. Is that okay? Now there is a substituent here too. 4, 5. Oh, sorry. Let's do that again. So it has to be in descending order, right? Okay. So we have 1, 2, 3, 4. We have 1, 2, 3, 4, 5, 6, 7, 8. Then this will now be in the middle, right? So it will now look like this molecule is something like this. Something like this. Something like this. So that the bridgehead carbon will now be here. In between this, we have 3 here. So we can now go, so good. So we can now go like this. 1, okay. We still give order to, we still go in the direction of the highest, so don't confuse it. We still go in the direction of the highest. So this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. So we're gonna have bicyclo 4, 3, 2, 9. That is known. Okay, there's 5 ethyl. 5 ethyl. 5 ethyl known. Now this 9. Okay. Yeah, it's supposed to be this. Go from this to this, then to this. This is going to be what? Okay. So it's going to be ethyl, because it's 9, this will be 10 and 11. Okay? So that will be on deck 10 in. Wow, that looks very big. But anyways, that's going to be the name. Okay, let's look at this spider looking one. weird looking one, looking like an insect. Okay, so this same way we have our bridged carbons, this guy and this guy here, right? So we're going to go in what direction? Obviously this direction, because this is 1, 2, 3, 4 carbons, and here 1, 2, 3 carbons. So we're going this direction. So we have bicyclo 4 because of 4, 3, 1, the guy in the middle. Then we have many substitutions here, but we are still going in this direction. There will be 1 on carbon 1, we have double 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So that will be 2 methyl, 9 methyl. So that will be 2, 9 dimethyl, dimethyl, 6, 7, 8 triethyl, 6, 7, 8 triethyl, there's no dash here, dec, 1 in, right? So decene or decene, whatever that is. So that is the name of this molecule. With this, we come to the end of the video. Do well to subscribe to the channel. I hope that you have learned a lot from this series. Make sure you keep following me, and anything that you find confusing, do well to drop it in the comment section. Drop it in the comment section and ask me to make video on it for you. I'm going to do so. God bless you as you do so, and share the video with your friends. God bless you.